Substances that flow are called fluids. All liquids and gases are fluids. In order to understand the concept of buoyant force, let us have this demonstration. Let us have a bucket filled with water. Try to push a ball into the water. We feel an upward push. We now push it further down. We feel it difficult to push it further deeper. So it looks some kind of upward force must be acting on the ball. Question is, where does it comes from? In fact, it is the act of water that exerts this upward force. It can be easily shown by releasing the ball. It is immediately bounces up to the surface. Such an upward push is called buoyant force. And the property of coming up to the surface is called buoyancy. Let us now place a piece of stone on the surface of water in a beaker. What we observe is that piece of stone sinks. Why? In fact, gravitational force of attraction pulls the stone downward. At the same time, upthrust of water acts on stone upwards. Out of these two opposite forces, gravitational force on stone is more than upthrust, hence stone sink. But if we take cork instead of a piece of stone, upthrust is more than gravitational force on cork, hence object will float. Floating or sinking of objects can also be explained on the basis of densities. We have seen cork floats while the stone sinks. Reason is difference in their densities. Density of a substance can be defined as mass per unit volume. The density of cork is less than the density of water, hence float. On the other hand, stone having greater density than water, therefore sink. This means that the upthrust of water on the cork is greater than its weight, therefore floats. Similarly, upthrust on stone is less than its weight, therefore sink. Let us have a stone tied with a spring balance. Note down its weight. We dip stone slowly and slowly into water. Reading of spring balance gradually decreasing. No change in the reading observed when stone gets fully immersed. Why so happen? Note, when stone is immersed in water, an equivalent amount water is displaced. Reading in spring balance can be observed. This is due to buoyant force, which can be well understood by Archimedes Principle, which states, when a body is immersed fully or partially in a fluid, it experiences an upward force that is equal to the weight of the fluid displaced by it. If you look at the figure, two forces acting are the weight due to gravity, upthrust provided by the liquid, so apparent weight equal to weight in air minus upthrust. A ball is thrown vertically upwards with a velocity of 49 meters per second. Calculate I, the maximum height to which it rises, E, the total time it takes to return to the surface of the earth. Let a ball is thrown up with a velocity U equals 49 meters per s. Ball reaches maximum height when V equals 0. Now, as we know, V varg equals U varg minus 2gh. Putting values, we get 0 equals 49 to the power of 2 minus 2 guna 9.8 guna h. Implies that h equals 49 varg upon 19.6 equals 122.5 meters. Let t is the time taken to rise to the maximum height h. V equals u minus gt. Putting v equals 0 at the maximum height h. Putting values, we get 0 equals 49 minus 9.8 t. Therefore, t equals 49 upon 9.8 equals 5. Hence total time taken to come back to its original position equals 5 plus 5 equals 10 seconds, because time taken to ascend is equal to time taken to descend. A stone is thrown vertically upward with an initial velocity of 40 meters per second, taking g equals 10 meters per square second. Find the maximum height reached by the stone. What is the net displacement and the total distance covered by the stone? When a stone is thrown up with 40 meters per second, maximum height will be achieved when v equals 0. Hence, v varg equals u varg minus 2gh. Putting values, we get 0 equals 40 square minus 2 guna 10 h. Hence h equals 1600 upon 20 equals 80 meters. Since the stone after reaching the maximum height comes back to the same position, Therefore, displacement equals 0, distance traveled equals 80 जोड़ 8 शून्य equals 160 meters. A girl stands on a box having 60 centimeters length, 40 centimeters breadth and 20 centimeters width in 3 ways. In which of the following cases, pressure exerted by the brick will be a. Maximum when length and breadth form the base when breadth and width form the base, b. Maximum when breadth and width form the base, c. Maximum when width and length form the base, d. The same in all the above 3 cases. Given L equals 60 centimeters, B equals 40 centimeters and H equals 20 centimeters. As we know, pressure is maximum when area of base is minimum, so answer is B.